Hello there. Okay, so this is my 3D printer enclosure that I'd like to show you. It's 3D printing, so I'm going to be able to show you what are the problems I would like to solve in this video. So I've got one problem that's caused by multiple different issues. So the problem I've got is this filament sometimes gets stuck on this feeder, and therefore sometimes the print kind of stops but not completely. Sometimes I get weak layers, so as you can see I can really separate them by hand very easily. So this is obviously a big no-no, and I cannot use these prints. This is why the main unit is pulled out and I cannot close the cupboard right now. That's because I need to minimize the angle at which the filament is being put into the feeder. So this is not the original part. The original part is right here. And as you can see, over the ages, I've had it for quite a few years, the filament, after being put in through odd angles, ate away at the plastic slowly but surely. So to solve this problem, I got the metallic part. But the metallic part does not yield to the filament, which means that sometimes it gets stuck. As you can see, if I can click closer, you get this plastic dust. This is the filament that's been grinded onto the metallic feeder. So what I'd like to do is threefold. First, I'd like to be able to put this main unit back where it was normally. I'd like to put the filament up there using one of my spool holders I designed. I'll probably have to modify it a little bit as it can't be used as it is. And lastly, I'd like the filament to go in straight. So for that very last part, I was thinking about using ball bearings such as this one. I've got quite a few laying around, a few spare ones, but it would be a massive hassle to design it, and I'm not looking forward to do that. So instead, the solution I came up with is using spare parts I've got for my 3D printer. So this is for the Bowden tube, which is the one that's feeding the plastic just there, the white one. As you can see, I've got quite a lot of spare. I've got these all out for the video. Normally they're nice and tidied up in my cupboards. So what I'd like to do is have something that fits in here. So it's probably going to clamp here and glued using hot glue. And I'll probably have two of these, and the Bowden tube is going to be the 90-degree angle. Or have it float loosely after being put inside of one of these. So I don't know yet what kind of design I'm going to come up with, but what I'd like to do in the end is being able to accommodate a wide variety of angles. Let's say I want to put it over there, I'd like to put it over here, whatever. I'd like for the filaments to go in straight without having those feed issues. So this is the problem I'm going to try and solve in this video, and I'm going to show you the design right now. Now, before I go on to designing anything, I obviously need to measure everything. In this case, however, I won't be able to show them as a very simple reason. There's too many measurements to do, and I can't hold the camera for weird angles for that long. So use the ruler, use the caliper, and what I came up with is this little paper that pretty much showed how many measurements I had to do. So measuring all over the place, I've got see this sheet of metal right here is slightly angled, so it's not a 90-degree angle, had to account for that. Plenty of little measurements, so had to measure, remeasure, measure again, just to make sure everything was a very nice fit, and to minimize the amount of prototyping I would have to do to make sure I had something that would fit. So there you go. Now for the motherboard elevation, so what I'd like to do is, as you can see, this is the output fan, and those little stubby little links are not enough. They give very little clearance, which means the motherboard heats a lot, and I'd like it to last a lot longer than it already lasted. So what I'm going to do is I'm going to elevate it. So I've been using all kinds of stuff to prop it up a little bit higher. What I'm going to do is I'm just going to make something that's going to use those little feet to stay in place. So I have to measure them off camera because, as you can see, I've only got 2 hands. But the gist of it is I'm just going to measure the size of those cones, the spacing between those little cones, which are the feet, and make sure I design something that's just going to stay in place and not move at all, and therefore allow me to just make sure that this motherboard is going to last a lot longer. I think this 3D printer is close to 5 years old, I think, so it's quite old and I really like it. I'd like to keep it for quite a few more years, so in order to do that I need to take proper care of it. So the very first thing I'm going to design is the filament holder. So since I've got the spore holder which pretty much fit the bill but did not have enough clearance, so what I'm going to do is I'm just going to duplicate the project, and I'm going to give it the clearance it needs, because the spore holder, when I tried to put a filament on it, what happened was the filament was rubbing against the wall and therefore was not turning correctly. So disassembling everything, extending the lengths when necessary, reassembling it, and then just putting it on the 3D print bed and making sure everything fits nice and tight. For the part that's going to elevate the motherboard, it was really as simple as just making a rectangle of the right length, adding 2 cylinders, and then hollowing out the cylinders to accommodate the legs of the motherboard, or central unit, depending on how you want to call it. And then all I had to do was put it on the build plate, and that was it, really as simple as that. Okay, so this is by far the design that has the most constraints I ever designed at all. I already designed pieces that were more complex than this, but they by far did not have as many constraints to respect to fit into place. So this weird L shape that you're seeing me do right now is because I need to go around the vertical bearing that allows the elevation of the hot end. The diagonal cube that I'm using as a whole is to make it easier to snap into place, and these are just a few examples of all of the design choices I'm trying to come up with and trying to design everything. So I'm just going back and forth, trying to measure everything, re-measure everything, making absolutely certain that this is going to be right on as few tries as possible. I've already got experience with some pieces that I had to design over 12 times, and I'd much rather not do that if possible. So each time you see one of those little pauses, that's me going back to the 3D print, taking out the measuring tape, the ruler, and the caliper to try and get the exact dimensions. All of those 45-degree angled triangles are to serve as supports, because I'm anticipating that there's going to be a lot of stress on the long run with the filament being pulled, pushed, then put everything on the print bed, and I just print everything at once to save a bit on the time. Now, as you've seen in the previous video, I just have to hot glue the caps onto the curtain hanger. This is just to make sure it doesn't slide off laterally. Installing the filament holder was a bit trickier than what I thought it was going to be. As you can see, the interior of my cupboard is filled with sound foam. This is to allow me to print at night, as I'm not woken up by the 3D printer when it's working. The inconvenience here is I did have to remove it to place the holder itself, but I also had to remove quite a lot of it to accommodate for the spools, because even though I did give myself enough clearance for the wall directly, or the side of the cupboard for that matter, I did not give myself enough clearance for some sound foam. So I had to remove that, and only then was I able to have the end result. Okay, so as it turns out, this piece is an amazing fit. Much better than what I anticipated. Really good. The problem is, as you can see, I drilled that hole very slightly. Let me turn the camera for you. So I drilled the hole very slightly, because as I purposely designed it to be very slightly smaller than the thread, because I really wanted the thread to bite into that hole, I did not realize, but this meant in turn that now the hole is a bit too small, so I was overzealous, And this means that even though I did dig it out a little bit by hand, I'd much rather reprint it properly and have something that's a very nice fit. So I think I'm missing 0.5 millimeter, not much more. But anyway, on the rest, as you can see, it's a very good fit. So I was not expecting it to fit so nicely behind the motor. As a matter of fact, I'd completely forgotten about said motor when I did all of my measurements. So this turned out to be a very nice coincidence. And for the rest, it's just very good. So all of these measurements really did pay out well. So normally I should only have to print one last version and should be all good. As a side note before I go on, the fit is so good that I'll probably not need any hot glue, which is way beyond my expectancies. So as you can see, I've got very little amount of play, but since the filament is going to be coming in from that direction, I'm really not, I'm not worried about it, and I can always add the hot glue after, should I ever need to. But yeah, this is turning out really well. Now, for the parts that elevate the motherboard of the 3D printer, they weren't as good. I wasn't expecting them to succeed on the first try. So if I go down a little bit, what seems to have happened is my cones, holes, whatever, are not as aligned as I thought they were going to be. So they're too far spaced out. So all I need to do is get them closer a little bit. I could technically use it as it is, but I'd like something that's really 100% designed as I wanted it to be. So getting these holes a little bit closer and voila, should be fine. So this was really just as simple as disassembling everything, increasing the hole size by 0.5 millimeter, lowering said hole a little bit just to make sure it's nice and aligned. I then check everything to make sure everything is all good, and then I export it on the old to make a cure, which needs to be cleared before I can place the filament redirection. Redesigning the motherboard elevator really was just as simple. I took a few extra measurements to check how much I had to shorten the object. I then disassembled, reassembled, and then put it onto the Ultimaker build plate in order to print everything at once. Okay, so here is the completed end result with all of the parts that I've 3D printed and assembled. I'll just start by the filament holder. So as you can see, it's nicely installed. It really works. 2 filaments side by side, and it does exactly what I designed it for, which is really pleasant. Next is the main unit / motherboard elevation, so version number 2, and works very well. I can move it around, it stays underneath nicely. It's a very nice fit. Here's version number 1, and I'm probably going to be repurposing it by stacking it right here with hot glue to prevent this cable from sliding underneath. So currently it's not glued. I'll probably do that in the future. And last but not least, the star of the show would be the filament redirection, and it works. It's absolutely awesome. It really is. Complete success. So here's the Bowden tube, here is the connector part, forgot how that one is called, and here it is. So it's really nicely fit in place. I can't put it, I need a lot of force. It moves a little bit, but I really would need to pull it with both hands if I wanted to take it out. So I've test printed a cup holder, and it really did work nicely. So this is going to allow me to go back into 3D printing very big stuff, such as the screen holder, which should be video number 4 on my 3D designs. So there you go. Thanks a lot for watching. Bye bye.